Welcome to Node.js Interactive. This is a talk on HTTP3 quick update. Remember that this is experimental, so do not try it in production. If you try it in production, do not blame me. My name is Trivikram Kamat. I am software development engineer. My Twitter handle is Trivikram and GitHub handle is Trivikr. If you see, I did not get Trivikram handle on GitHub. That is because I joined GitHub late in 2015 and somebody else has taken it already. So if you have become parents recently, get GitHub handle for your kids because that's more important than other social media. So the hashtag for Node.js Interactive is hashtag Node.js Interactive if you're active on social media. You can also use HTTP3 or QUIC if you like this talk. If you didn't like this talk, then use my name. And what's my name again? Most of you will have forgotten. So I'll give a clue. Okay. So we are in Canada and it is very cold and you will be knowing this drink. It's called rum. It gives a lot of warmth. So imagine a weak rum, not a strong rum, a weak rum, and add tree in front of it. That's my name. So what's my history with Node.js? I've been using Node.js for 4 years now. I started contributing to Node.js core in October 2017. Helped make HTTP2 stable. I wrote unit tests and fixed some bugs. You can do the same with HTTP3. We'll cover that. I became Node.js core collaborator in March 2018, and I organized and mentored 4 code and learn events. What are we going to cover in this talk? We are going to cover what is HTTP 1.1 and why HTTP 2 was required. Then we'll cover what is HTTP 2 and why HTTP 3 was required. Then we'll cover what is HTTP 3 and when is it coming. It's still draft, it's still experiment, when is it coming? And we'll see some sample code on the way. So I would like to thank James Snell, who is here. He's a Node.js technical steering committee member and heading the work on implementing QUIC. Thanks, James. And I'd also like to thank the sponsors for his work, that is Protocol Labs and Nearform. I will also like to thank Anna Henningsen. As James says, she fixes the bugs which he introduces. And I'll also thank Daniel, Juan, Ouyang, and many others who have contributed to QUIC already. I'd also like to thank Tatsuhiro-san for his awesome work in ngTCP2. We are using ngTCP2 for implementing QUIC, and he has done some amazing work. So let's start with HTTP 0.9, which was published in 1991. And it was very simple, it was just one-line protocol. Okay. You get mypage.html, you send get mypage.html, and you get mypage.html. Awesome, right? Life was so simple back in 1991, but things had to get complicated. So HTTP 1.0 got introduced in May 1996. And it built extensibility. Let us see what it did. Okay, this is how you send requests, this is what the response you get. So now you can send version information because now there is more than one HTTP protocol. You also send browser information because there are multiple browsers. And then you send status code because not all requests are successful. Sometimes there are redirect requests, sometimes there is a client error, sometimes a server error. Then there are headers with date information, what kind of server is there, okay? What kind of content type. So instead of sending content text, you can even send JSON and other types. And then we could include multiple resources in the HTML file. So in this HTML file, there is an image being used. So then HTTP 1.1, the standardized protocol came in June 1999. And I will not go through the headers because there are too many headers. We will just see what were the improvements in HTTP 1.1. So first improvement was persistent connection, in which you can use single TCP connection to send and receive multiple requests and responses which are serial, not the concurrent ones, which are serial. And there was pipelining, in which second request can be sent before the first one is fully transmitted. And there was chunk transfer encoding, and there was additional cache control mechanism, there was content negotiation. We will see what were the issues with HTTP 1.1. So first issue is 3 round trips per request. So this client in a server, and this is from a blog post from Cloudflare, they have written a very good description. So client sends a TCP SYN packet. Then server sends TCP SYN plus ACK. Client sends TCP ACK. Then client says TLS client hello. Server says TLS server hello. Then client says TLS finished. Still the request is not sent, okay? Then HTTP request is sent, HTTP response comes. Who has time for this? Okay, 3 round trips per TCP connection. Let's revisit this later. Issue number 2 was multiple TCP plus TLS connections were created for concurrent requests. So how does this happen? Like you write applications, right? In those applications, you will be importing images, you will be importing CSS, you will be importing JS. And these things have to be imported concurrently. And when that happens, multiple TCP connections are created, and for each TCP connection, there are 3 round trips as we saw. So it takes a lot of time. So let us understand this by going through the code, because talking is boring. So let us see the code. Okay. If you have attended Matteo's talk on streams, he mentioned today that do not use pipe because it uses memory leaks. Anyway, just ignore that. Use some framework, yeah. But here we are just writing normal create HTTP create server. So if a request URL is hash, just return index. If it is style.css, it return that. Okay, that's it. So I'll just made it simpler. So if request URL is the home page, return index.html, and otherwise just a regular expression which reads what the file name is and return that file name from the files folder. Okay. Let us go through the code because it is important. We'll see how it works in HTTP 1 and 2 and 3. So index.html, you import style at the top, okay. Then you import an image in the body. Then you say hello world, because in the first program you have to say hello world. And then we import a script. Let us go one by one what each files do. So style.css is just CSS, like just body displays flex, whatever, yeah. Just CSS. What script does is that it finds the name and changes it to Node.js interactive, because we had Node.js interactive. So it will say hello Node.js interactive, and it will change the image, the globe image, to Node.js interactive image. Cool? That's after a second. Yeah, after 1 second. Wait for a second. And this is just a globe image. So let's see how it looks. So I'll just enable loop and play. So here you can see that we are requesting localhost first, and then 3 concurrent requests are sent for CSS, JS and image, and then the JavaScript is executed after a second, the set timeout, and then the image is sent and Node.js interactive image is shown. Let us see how many TCP ports are created. It's very different. So below I have a command, telnet command, which looks for how many TCP connections are created. When you see that request is sent for localhost, only 1 TCP connections are created. It shows 3 records, but only 1 is created. But then when it has to make 3 concurrent requests, you can see multiple TCP connections are created. That is the issue with HTTP 1.1. So what are the issues with HTTP 1.1? One was 3 round trips per request that we saw, and second one was multiple TCP TLS connections for concurrent requests. Now what did HTTP 2 do? It was published in May 2015, and you saw that 3 requests are sent for 3 resources in HTTP 1.1. In HTTP 2, only 1 TCP connection is created, although all 3 resources are fetched. So let us see how it works. So we write a HTTP 2 server. So you create a server and then if it is slash, you return index.html, and otherwise you get the regular expression, that file. And let me so if you examine using the network tab, it will be same as HTTP 1.1, only in the protocol column you will see that H2 is used. Okay, so you don't see that how many TCP connections are used. So I go to next slide, and I watch for TCP connections using netstat command, and you will see that only one TCP connections are created, although 3 requests are sent simultaneously. So let us see the benefits of HTTP2. We saw the one benefit, which is multiplexing and concurrency. So different HTTP requests are sent onto the same TCP connection. But there are some other benefits also, like stream dependencies. Clients can indicate to server which dependencies are important. There is HPAC header compression, where it reduces the length of the header field encodings by exploiting the redundancy, because headers have a lot of redundant code, so it can be encoded. And there is server push, so server can send resources with clients have not requested yet, but we will not go through that in detail. We'll just see the issues with HTTP2, because if there are no issues with HTTP2, HTTP3 will not exist. So let's see the first issue. HPAC is stateful. So the encoding and decoding tables have to be maintained at the endpoint. So because of which, so what happens, each packet is sent, so first time it encodes something, and when second packet is sent, it will use the encoded content, it will send the new content only if there are some changes. So that is one issue. Delta encoding is used in header compression. So this causes high resource consumption in real time, then it's not easily routable along the network. And the main issue which we will discuss in today's talk is TCP head of line blocking. So what is TCP head of line blocking? When a single TCP packet is lost or corrupted, all subsequent packets are blocked until the lost one can be successfully transmitted. In HTTP 1.1, if this happens, you are blocking only one request, because there is only one request, HTTP request sent over a TCP connection. But in HTTP 2, since multiple requests and responses are carried over a single TCP connection, all those request responses will be blocked. So let us understand this using a, so before that, we will see where this effect is most significant. It is most significant on high latency networks, which are long distance. So if there is high latency, probability of packet getting lost is more, or on mobile connections, where probability of getting packet lost is more. So we'll understand this using a chain metaphor. So this is a chain. Imagine this is a TCP connection between two computers, and what I've done is I put green colors and red colors, where green color consider that's a CSS packet, and red color is JS packet, where CSS and JS files are requested over the same TCP connection. If a JS packet is lost or corrupted, then the entire chain is broken. So the entire chain post that JS packet, which includes CSS packets, have to be sent again. This is explained very well in HTTP3 explained if you want more details. So what does HTTP3 over QUIC does? So this is draft 24 as of December 2019. So what it does is that when it is setting up multiple streams over QUIC connection, they are treated independently. So that if any packet goes missing in one of the streams, only that stream has to pause and wait for the missing packet to get transmitted. So to understand this, let us see the chain analogy, in which this is CSS stream, this is JS stream. If the JS stream packet is lost, the CSS stream is not affected. Now you will say, isn't this what HTTP1 was doing? Are we going back? No, because HTTP3 is built on top of UDP. So on the left side you can see HTTP2, which is built on top of TCP, and HTTP3 is built on top of UDP, and QUIC comes there in between. Speaking of UDP, I can tell you a joke, but most of you won't get it. Got it? Got it? Got it? You didn't get it. Let me still give it a try. UDP packet bar box into a. Did you get it now? So QUIC adds the following to UDP. Okay, it adds error handling, it adds acknowledgement, it adds flow control, it adds packet sequencing, built-in encryption, TLS 1.3, and bidirectional unidirectional streams. So whatever benefits you have on TCP, those goodies will come to QUIC. Amazing, right? And QUIC also reduces round trips. Remember, we saw that 3 round trips per request. Who has time for that? So in UDP, it will take on, if each round trip takes 100 milliseconds, in QUIC it will take just 100 milliseconds for the first request, or if client knows the server already, it will take 0 millisecond. So before we write the HTTP server, remember this, QUIC is not equal to HTTP3. Okay, these terms will be used interchangeably, but they are not the same. So HTTP3 is an application protocol which uses QUIC as a transport protocol. So you have HTTP3 on top of QUIC, then on top of UDP, and then IP. The Node.js implementation will let you create your own alternative protocols on top of QUIC. One place where we are considering using QUIC is for inspector protocol. We currently use WebSockets, but we may switch to QUIC, or in diagnostics. Similarly, you can create your own application protocol over QUIC. Like DNS. DNS might also use QUIC. So let us see the HTTP3 server. Of course, when you request / you get index, otherwise you request the file name, and you load the web page, and you get this site can't be reached. Why? Because it is experimental. Okay, you cannot use it in production. It's experimental, but we have done a lot of progress. So it is an early stage of development, but you can help build it. You can help build it. You can help build it. How? Go to Node.js QUIC. So this is the progress we currently have, around 70% done, and this is the project board, and this is slightly outdated, but you will be wondering, oh, like I want to contribute. I can see all the excitement in each one of your eyes that you want to contribute to QUIC, but you will be wondering, oh, like I don't know anything, how do I contribute? It's very easy. Write tests. Start with writing unit tests. It's amazing. When you write unit tests, you'll find bugs, and you'll fix those bugs, and then you can also become a collaborator like me. So how can I write unit tests? I'm glad that you asked. So you go to Node.js QUIC, you fork it, and then you clone it, then you say experimental QUIC because it is experimental, get the coverage, and these are the results, slightly old, but this is what we have for JavaScript. So if you're into JavaScript, you can help writing unit tests in JavaScript, and we need more help in writing C++ tests because there is a lot of code in C++. So now this is how to contribute to QUIC in HTTP3, but if you want to go more deep and contribute to the protocol itself, then HTTP3 protocol is a IETF draft 24 right now. So you can join their meetings and suggest. So we'll still see an example web page on QUIC, that is quick.rock. So this is how it looks. So when you examine in it, at the bottom you will see that the protocol is HTTP2 plus QUIC. So let's go through demo. The Node.js did not build on my machine quick, so I'll show the demo which James showed. So in NodeConf EU. So I'll just
there we go. So this is one of our tests that we're using, and I have debug tracing enabled. Basically, you're just going to see a bunch of text flying across the screen, but it's a client talking to the server, sending a copy of the test file itself back and forth. All right? But I want to, once it's through, I want to point out a few things that we see in the results. So this is, sending all the UDP packets. This is all the trace information. It'll take just a second here. But it actually works, which I'm super happy about because last week this was seg faulting like crazy. All right. So we see here at the end when in these objects, and all this information is available to the JavaScript layer. But we have here, you can see the bytes sent, right? You can see the number of streams that were created. If you scroll up here a little bit further, we'll see that, you know, how many bytes were received on a particular session, when the handshake started, when it completed. This is all information that's going to be available at the JavaScript API layer, just built in here. So right now, this is information that you would have to install additional modules to get in other things within Node. This is all going to be built into the API and available.
Cool. So let's have a summary of what we learned. In HTTP 1.1, multiple TCP plus TLS connections were required for concurrent request. In HTTP 2, added multiplexing, in which multiple HTTP requests were sent on the same TCP connection. TCP head of line blocking, in which is the one in which the entire TCP connection is brought to an halt if a single TCP packet is lost. And HTTP 3 over QUIC treats each stream independently, so that if any packet goes missing in a stream, only that stream is affected. That's it. Thank you for listening. My name is Trivikram Kamat. All the code which I showed is present on GitHub, and the slides are available there. Thanks.